A circuit is said to be in parallel when the voltage is the same across the resistors. The current is branched out and recombines when branches meet at a common point. A resistor can be connected and disconnected easily without affecting other elements in a parallel circuit. Resistors are said to be connected in parallel when both terminals are respectively connected to each terminal of the resistor or resistors. In a parallel network, the circuit current can take more than one path as there are multiple paths for the current.
At this juncture, I will present and tackle to you the objectives, material in the diagram of the experiment. The objectives of this laboratory experiment is to verify the principles that govern the resistance which are connected in parallel. The specific material or apparatus that was utilized is the PHET simulator, circular construction kit DC or direct current. The following slides that will present are the diagram from trial 1 to trial 3. Each diagram includes two resistors, a battery, switch, and some wires in order to determine the current and the voltage. Additionally, the 3 ammeters and a 2 voltmeter are also included, which are also the essential parts of the simulator circuit.
Procedure. We, the students, access the PHET simulator circuit construction kit DC. Then we identify the important parts of the circuit and analyze how to utilize the respective apparatus. The PHET simulator includes the wire, battery, light bulb, switch, voltmeter, and ammeters. To construct the circuit, first drag 2 voltmeters and 3 ammeters followed by the wires, battery, and 2 fixed resistors. Lastly, we drag the switch. These materials that were dragged in the medium of the screen of the PHET simulator were respectively placed in according to the student's choice of layout. Third, connect the ammeters, switch, battery, and resistors using the wires. The value of resistance can be changed comparing to the student's choice. Then, connect the probes of the voltmeters to the opposite sides of the resistors and eventually determine the value of its resistance, current, and voltage. In order to close the circuit, simply click the bottom part of the switch. Note that we arrange the circuit in parallel connection. When the values are already shown or revealed, take note of it right away. Encode the following data shown from trial 1 to trial 3 in the table given in the laboratory experiment number 6 worksheet. Take note that the value of the battery in voltage is held constant. After encoding the data of each trial, understand and analyze the diagrams thoroughly. Lastly, we proceed to the next parts of the experiment by answering the computation, discussion, observation, analysis, and conclusion.
Tables and computation. At this moment of time, let me discuss the tables and computation of the laboratory experiment from trial 1 to trial 3. The value of resistant 1 and resistant 2 are correspondingly increasing. This results to the total value of resistance is also increasing. In finding the value of total resistance, we add up the value of resistant 1 and resistant 2 in each trials. Then we find the reciprocal of the sum. Specifically, the total resistance from trial 1 to trial 3 has the value of 6 ohms, 8.57 ohms, and 11.11 ohms. In terms of current, the value of current 1 and current 2 are correspondingly decreasing, but not the same to the value of total current. In current 1, the values from trial 1 and to trial 3 are 3 amperes, 2 amperes, and 1.50 amperes. In current 2, the values are 2 amperes, 1.50 amperes, and 1.20 amperes. To be specific, the total current from trial 1 to trial 3 are decreasing with the value of 5 amperes, 3.50 amperes, and 2.70 amperes. When it comes to voltage 1, its value is the same from voltage 2 and the total voltage. From voltage 1, voltage 2 and voltage 3, their values from trial 1 to trial 2 is 30 volts. The following images are the tables and computation of this laboratory experiment. In order for you to understand in verifying the principle, the government resistance which are connected in the series.
Hi, I'm Joshua Daniel Casco and I'm gonna present to you the discussion in our lab experiment. Resistors are in parallel when the two terminals connect to the same nodes. Resistors in parallel share the same voltage on their terminals. The overall resistance is the reciprocal of the sum of reciprocals of the individual resistors. Resistors are in parallel when one end of all the resistors are connected by a continuous wire of negligible resistance and the other end of all resistors are also connected to one another through a continuous wire of negligible resistance. Currents through each resistor can be found using Ohm's law, I equals to V, or Ri equals to V divided by R, where the voltage is constant across each resistors. When resistors are connected in parallel, more current flows from the source than would flow for any of them individually, so the total resistance is lower. We can define a parallel connected resistance as one where the resistors are connected to the same 2 points or nodes and is identified by the fact that it has more than one current path connected to a common voltage source.
Observation. In the first trial, the first and the second resistors have the values of 10 ohms and 15 ohms respectively. Using the equation for parallel connected resistors, we get the value of the total resistance at 6 ohms. Using the voltmeters, the current values for the first and second resistors is 3 ampere and 2 ampere, adding to a total current of 5 ampere. In the second trial, the first and the second resistors have the values of 15 ohms and 20 ohms respectively. Using the equation for parallel connected resistors, we get the value of total resistance at 8.57 ohms. Using the voltmeters, the current values of the first and the second resistor is 2 ampere and 1.50 ampere, adding to a total current of 3.50 ampere. In the third trial, the first and second resistors have the values of 20 ohms and 25 ohms respectively. Using the equation for parallel connected resistors, we get the value of total resistance at 11.11 ohms. Using the voltmeters, the current values for the first and second resistor is 1.50 ampere and 1.20 ampere, adding to a total current of 2.70 ampere. In this experiment, we observed that as we increase the resistance in each trial, the current decreases. We also observed that the total current equals to the addition of current 1 and current 2 and so on, and that their voltage is all the same as the total voltage.
For the analysis, we examined the formula that we use to calculate the equivalent resistance of a parallel network. We will find that adding any amount of parallel resistance will always result in a lower equivalent resistance. Even adding a very large parallel resistance will cause the resistance of the entire network to decrease. It follows that the equivalent resistance of a parallel network will always be smaller than the smallest individual resistance in a network. Any quantity of resistance that we connect between the two nodes will allow at least a little bit of current to flow through this new branch. By adding resistance, we are actually creating a new pathway for current, and an increase in overall current corresponds to a decrease in overall resistance.
Conclusion. Based on the results in the table, as resistance increases, its total resistance will increase and the current also decreases. Therefore, adding more parallel resistances to the paths causes the total resistance in the circuit to decrease. Adding more branches to the circuit, the total current will increase because Ohm's law states that the lower the resistance, the higher the current. The more of the resistors are added in parallel to a circuit, the total resistance of the circuit decreases and the total current of the circuit increases. Adding more resistors in parallel is equivalent to providing more branches through which charge can flow. Even though the added branches offer resistance to the flow of charge, the overall resistance decreases due to the fact that there are additional pathways available for charge flow.